Okay, Workplace 11. Welcome to section 1.1 on ratios and proportions. This could very likely be the first lesson. Not necessarily, depends which order we do the course, but this is quite possibly the first lesson. And look at me, genius that I am. I've made the course seem completely infantile, like it's aimed at kindergarten kids. I'm sorry. I don't know why I picked chickens and cows and frogs here. I should have put things that are really cool to grade 11s, like, I don't know, army tanks and TikTok stars and rap icons. But I figured having pictures of Charlie D'Amelio and Future, I don't know. I thought this was easier. So I'm sorry. I don't want to make it seem like this is a course for kindergarten kids. It is not indeed a course like that. So in this lesson today, we're going to talk about ratios and proportions. Very important topics. So you've talked about ratios before, but you may not remember. So let's remind you. A ratio is a comparison between two or more quantities with the same units. So this part about units, we're not going to focus on too much today. We'll probably talk about it next day or the day after. The idea is that you can't make a ratio that compares, for example, centimeters to meters. You'd have to switch one to the other unit. But we won't worry about that today, so let's just leave that for today. They can be written in three different ways. So let's say, for example, I wanted to write a ratio comparing how many letters there are in the word ratio and how many letters there are in the word proportions. Sorry, ratios and proportions. So I count up ratios. 1, 2, 3, 4, 5, 6 letters make up ratios. And if I count up proportions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we got 6, we got 11. So there's three ways I could write the ratio. I could write it like this. 6 dot dot, what's that, a colon? Yeah, 6 colon 11. That's one way to write the ratio. Now, how do you say this? You don't say 6 colon 11. You say 6 to 11. It's a comparison. You're comparing 6 to 11. Well, actually, it turns out that's the second way you could write the ratio. You could also write 6 to 11. So they both say the same thing, 6 to 11, 6 to 11, but one's with a colon, one's with the word to. The other way, the third way you could write this, is you could actually write it like this. Whoa, what's that look like? A fraction. It is a fraction. A fraction is actually a type of ratio. Okay, so these are the three ways that we usually write ratios. I would say the most common is probably the first one with the colon. That's probably the way I'll do it for the most part. So let's whip through some of these. If I want to get the ratio of ducks to frogs up here, well, I look up here, ducks, 1, 2, 3 ducks. I look at frogs, 1, done. Okay, 3 to 1. I'm not going to do this for all of them, but you could also write 3 to 1. You could also write 3 to 1. Yep, that's how you'd write it, just like that. Okay, look at the next one, frogs to ducks. It's the same thing, isn't it? Am I going to write the same answers? No. Order is very important when you're doing ratios. So you see the first one, it was ducks to frogs. Now we got frogs to ducks. You got to count the frogs first. There's 1. You got to count the ducks next, 1, 2, 3. So it's just reversed, right? Instead of 3 to 1, it's now 1 to 3. Instead of 3 to 1 here, it would be 1 to 3. Instead of 3 over 1, it'd be 1 over 3. These are different from each other. 3 to 1 and 1 to 3 are different from each other. All right, whoa, look at this ratio. It has 3 things in it. Ducks to cows to frogs. That's fine. You just do the same sort of thing. So ducks, how many ducks do we got? 3. 3 ducks. How many cows do we have? 1, 2. 2 cows. How many frogs do we have? Just 1. So our ratio is 3 to 2 to 1. All right, there's one of these 3 forms. You know how we did the dot dot, the to, and the fraction? There's one we're not going to use. You know which one it is? The fraction. It just looks really weird when you have 3 or more things. So we could still write it this way. We could write 3 to 2 to 1. That's fine. So both of these are totally okay and totally equal to each other. You don't do this, 3 to 2 to 1. Nope, not doing it. If you have more than 2 things that you're comparing, you cannot use the fraction one. You can either use the colon or you can use the word to, but don't use the fraction if you have more than 2 comparisons. All right, next, frogs to camels. Okay, we count up the number of frogs. I see 1 frog. Look, he's telling us there's only 1 of me. Very helpful frog. There's 1 frog. How many camels? Let's count up all the camels. There's no camels. So we put 1 to 0. Who cares? It's fine. When you talk about ratios, you can definitely have zeros. So 1 frog to no camels. Next one. Frogs to other animals. Well, again, there's only 1 frog. He's still telling us that there's 1 frog there. How many other animals are there? I see 1, 2, 3, 4, 5 total other animals. So it would be 1 to 5. Next question, exactly the same, right? Frogs to animals. How many frogs are there? 1. It's not exactly the same. You know why? It says frogs to animals. What's different than other animals? If you just say animals, it means total animals. And when you say total animals, you have to include the frog. So you would actually count the frog once when you do the 1 here, but you have to count the frog when you do all the animals. So we actually have 1, 2, 3, 4, 5, and 6. Come on, frog, get 6 fingers up there. You've got 6 animals total. So this ratio would actually be 1 to 6. And just very quickly, all these ratios we've done so far have been a part to part ratio, right? Frogs to ducks. Frogs are part of all the animals. Ducks are part of all the animals. But when we did this frogs to animals or frogs to total animals, that's a part to whole ratio. Those are the 2 types of ratios there are, part to part and part to whole. When you usually did fractions, right, we could write this as a fraction, couldn't we? 1 over 6. When you usually write fractions in grade 7, 8, 9, 10, all that kind of stuff, it's always a part to whole fraction. You could also write this as a fraction, but this is different than fractions you've done before because this is a part to part. What you usually do is a part to whole. This is one of the reasons I'm not crazy about using fractions for the ratios, because it can get a little bit confusing, get them mixed up with regular fractions. All right, ducks to animals. So how many ducks are there? 1, 2, 3. So our first number is a 3. And in the second number, we need animals. We just counted all the animals. There are 1, 2, 3, 4, 5, 6. So we're going to go 3 to 6. Okay, before we move on, can anyone just have this feeling of what we might want to do with this ratio? There's something you can do with this ratio that we weren't able to do with any of the other ratios. I will tell you all the way back up here, we're going to write one more thing. We can write ratios in lowest terms sometimes. We can put them in lowest terms, right? Think about fractions when you talk about simplifying or reducing. I don't like using the term reducing, but hopefully that helps you understand what I'm talking about. 3 to 6, we could change that into a lowest terms ratio. You know what 3 to 6 would be in lowest terms? It would be 1 to 2. All right, someone's confused. I can hear it up there. They're like, huh? How do you do that? What do you do to get a fraction or a ratio into lowest terms? You ask yourself, what can I divide both of these numbers by? You have to be able to divide them both by the same thing. And don't divide them by 1. It doesn't make a difference. If I divide 3 by 1, I still have 3. It doesn't make any difference. Can I divide them both by 2? No, because 3 divided by 2 is some decimal. It doesn't work. But if I divide them both by 3, it'll work. 3 divided by 3 is 1. 6 divided by 3 is 2. So we've now put it in lowest terms. Okay, let's practice that a little more. Let's put these ratios in lowest terms. I've done one of each type. A fraction, the word 2, and the colon. And you can see I have a 3-term ratio here. Okay, 4 to 12. We want to put it in lowest terms. So you got to ask yourself, what could I divide both of these by? Okay, you might think, and you're not wrong, you could divide them both by 2. Right? If you divide by 2 and divide by 2, that's good. That'll give you 2, because 4 divided by 2 is 2, and 6. 12 divided by 2 is 6. But look, is that in lowest terms? No. You could still divide them by 2 again. Divide by 2, divide by 2. You end up with 2 divided by 2 is 1. 6 divided by 2 is 3. Now, what if I didn't want to do this in 2 steps? How could I have done that in 1 step? Remember, if you want to put things in lowest terms, always try to divide by the biggest thing possible. So rather than divided by 2 here, I could have divided top and bottom by 4 and 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So in that way, we could have done it in 1 step. Okay, the second one. 6 to 18. Same thing. You could divide them both by 2, but then you'd have to divide them by something else as well. Can you see a number that will be faster? What can you divide them both by? You can divide them both by 6 and 6. Okay, 6 divided by 6 is 1, and 18 divided by 6 is 3. Okay, this one's tough. You got to think of a number that you can go into that goes in evenly to all of these numbers, right? Don't pick something that only goes into two of them. It has to go into all of them. And the number I'm thinking of is 5. You can divide this by 5. You can divide this by 5. You can divide this by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. 15 divided by 5 is 3. So that's in lowest terms. As is this, as is this. All right, that's it for ratios for now. Let's talk about proportions, which actually includes ratios, because a proportion is a statement that two ratios are equal to each other. So for example, if I have one ratio like 6 over 8, and then I have another ratio, well, can you tell me what's a ratio I could put here that's equivalent or equal to this one? So here's what I can do. I can either divide both of these numbers by the same thing, or I can multiply them both by the same thing. But you can't do it with 0, you can't do it with 1, you can't do it with negatives. But let's say I multiply them both by 2. 6 times 2 is 12, 8 times 2 is 16. These are equal to each other. I could have divided them both by 2. 6 divided by 2 is 3, 8 divided by 2 is 4. These are all ratio. Are all equal, sorry, not all ratio. They are all ratios, but they're also all equal. I could multiply them by something big. Let's multiply by 10. It's not that big, but let's do it. 6 times 10 is 60. 8 times 10 is 80. Right? You can even, once you have an equivalent one, you can multiply that by something. Let's multiply the 3 and the 4 by 100. 3 times 100 is 300. 4 times 100 is 400. These are all equivalent ratios. They're all equal to each other. So a proportion is a statement like this, that two ratios or more are equal to each other. So what you're going to do, very important skill, is you're going to solve proportions where there's one number missing, right? You have one ratio here, 4 to 5. You have another one here, n over 20, and you got to figure out what's the number that's missing there. So the way you can always solve these is by cross multiplying. You don't have to solve them that way. There's other ways to solve them. For example, this one right here. What you might notice is to go from 5 to 20, what do? You multiply by 4. So if I do the same to the top, if I multiply by 4, I'll get what n is. 4 times 4 is 16. So I get the answer n equals 16. But sometimes you can't do that, right? Let's take a look at this one. What do I multiply 8 by to get 12? Ooh, that's hard. So I want to give you a method that will always work, and we call that method cross multiplying. It's kind of a trick. I'm not huge on tricks in math. I like you to actually understand. To really understand cross multiplying, you have to be pretty good at algebra, so maybe we'll get back to it later in the course. But let me give you an introduction to cross multiplying, although you must have done it if you've been in my class before, probably in other classes too. So there's 4 different types of questions, but they're all really the same. It just depends where the unknown amount, the n or the m or the x, just depends where it is. So let's say that I have the unknown amount here. Okay, we kind of have two diagonals, right? If I put an x here, I have this diagonal and I have this diagonal. But there's only one of those diagonals that I know both the numbers. I know both the numbers in this diagonal, 12 and 5. I do not know both the numbers in this diagonal because I only have one number. I just have the 10. I don't know what the n is. So what you do is you look for the diagonal where you know both the numbers, the 12 and the 5, and you're going to multiply them together. So n is equal to 12 times 5. But that leaves one number left over, the 10. So what do we do with that number? We're going to divide. So basically you're going to go 12 times 5, which is 60, divide by 10, you get n equals 6. Okay, you're always going to do that regardless of where the n or whatever is. What if I put 4 here, I put an f here, I put a, 11 here and a 9 here. So what's the diagonal where you know both the numbers? Not here, because there's an f. I don't know what f is. This is the diagonal this time. So how do I figure out what f is? I multiply the numbers on the diagonal. That's 4 times 9. And then I divide by 11. So that's equal to 9 times 4 is 36 divided by 11. And if you do 36 divided by 11, you're going to get a decimal, which is totally okay. You get 3.272727. If you know about repeating decimals, you could put the line over top. If you don't understand that, don't worry about it. Now, notice when you cross multiply, it is nicer if the ratios are written in fractional form. So if you came across a question like this, 5 to 12 equals m to 16. You know what I would do for the first thing? I would switch it to 5 over 12 equals m over 16, and then I would go ahead and do my cross multiplying. Oh, m is equal to 5 times 16 and then divided by 12. That's 80 divided by 12. Okay? All right, back to our actual worksheet that you're working on here. So now that we know how to cross multiply, we should be able to get these answers no problem. Notice I already got that answer, but let's just make sure it works. So what is our diagonal we know here? It's right here, the 4 and the 20. So in order to get our n, we're going to go 4 times 20 divided by 5. So n is equal to 80 divided by 5. And yes, 80 divided by 5 is 16. We got the answer. Okay, this one, what's the diagonal we know? Right here. So f is equal to 8 times 6 and then divided by 12. Well, 8 times 6 is 48 divided by 12. Oh, it's nice, it goes in evenly. 48 divided by 12 is 4. So there's our answer. Next one, we want to know what w is. Where's the 2 we know? This is the diagonal where we know both of them. So w is equal to 10 times 10, and then we're going to divide that by 8. So w is 100 divided by 8. W is equal to 12 and a half. Next one, this is probably overkill doing too many of them, but really want you to understand this. Here's the diagonal where we know both of them, the 15 and the 40. So x, the unknown, is equal to 15 times 40, or 40 times 15, doesn't matter, divided by 6. So x is equal to, whoa, big numbers here, is 600, and then we have to divide that by 6. Oh, that's not too bad. 600 divided by 6 is 100. All right, last one. It's one of these triple ratios, 3-term ratio. So how are we going to do that? Well, we're just going to break it down. We're going to look at 2 at a time. So let's get rid of one of them for the time being. Now, don't get rid of this one. Why would you not want to get rid of that one? Because then you'd have 2 unknowns, y and z, and that ain't going to work. You can only have 1 unknown. So either ignore the first ratio or ignore the third ratio to start. I don't know, I'll ignore the third one. So if I ignore this, I can solve this proportion right here exactly like we did up above. What's the diagonal where you know them both? Right here. So in order to get y, you have to go, you can't even read it now, it's 4 times 11. And then you have to divide it by 7. So y equals 44 divided by 7. If you do 44 divided by 7, you get 6.29 it rounds to. So that would be our answer for that one. Now, I'm going to erase all this. We need to get how much the z is now, right? We already got the y, but now we want the z. Any idea what to do? Ignore the first one this time. Here you go, you have another proportion here. So you do the same thing. What's the diagonal where you know them both? Right here, the 7 and the 18. So in order to get z, you have to do 7 times 18 and then divide by 11. 7 times 18 is 126, and we're going to divide that by 11. Good thing I got my calculator here. You get 11.45. It's actually repeating, so if you want to put the repeating sign, that's fine. Okay, that's ratios and proportions. Super important. We're going to be using this a lot in this course. Please master the cross multiplying. If you're having any troubles, I'm here to help. Take care, everyone. Bye-bye.